All right, so moving forward, we're on a domain problem. And the rule about domain is, if you have something in the denominator, it cannot be zero. So this is a situation of x squared minus 25 cannot be zero. And there's two ways to solve this. You could factor it, x minus 5 times x plus 5, not equal to zero, and then use the not zero product property. And that'd tell you that x cannot be 5 or negative 5. Or you could just move that 25 over, and the opposite of squaring is a square root. You just have to include the plus or minus symbol. That's the big thing. So x is not plus or minus 5 again. It's everything else. All right, find the square root. Smallest number you can take the square root of is 0. So the square root of anything, whatever's inside, has to be greater than or equal to 0. We're just going to set negative 2x minus 16 to be greater than or equal to 0. We're going to add 16. So now a negative 2x is greater than or equal to positive 16. We're going to divide by the negative symbol. So x is less than or equal to negative 8 because I divided by negative. Notice the symbolism changed. Less than or equal to negative 8. The difference quotient. I think about 3 of you got it last time. It's not that hard. We're going to find f of x plus h, which means that every x that I see is going to become x plus h. It's not that hard. So negative 4, there's an x plus h. I'm going to square it, so I'm going to go ahead and write it twice. Now I've got plus an x, so plus x plus h. This one's actually easier because I made it a plus symbol this time. That's sitting pretty over an h. Oh, ignore me. I'm finding this piece first. Let's see here. If we do x plus h, we have an x squared. We have an xh. We have another one of these. hx is the same as xh. We have an h squared. I don't need these parentheses because it's addition. Distribute, but focus on this. That's actually 2xh. So negative 4 x squared, negative 4 times 2, minus 8xh, negative 4 times h squared, negative 4h squared, plus x plus h. Now, at this point in time, I'm going to insert the rest of this, okay? Maybe. So I'm going to insert that h. I'm supposed to take away the original function, wrap before you subtract. And whatever you put in this set of parentheses, this should cancel. It should. So we have a negative times a negative was a positive. So there's actually a positive 4x squared here. So positive 4x squared minus 4x squared cancels. They're in balance. We had a take away a positive x. So if I have x and I take away x, there's my cancellation. That stuff's supposed to disappear. It always does. At least I've always seen it disappear. All right, so what are we left with? We're left with a negative 8xh minus a 4h squared plus an h all over an h. And I don't show this often. I only show it a handful of times, and I just expect kids to remember. But every single thing has an h. I can actually pull the h out. So I can pull it from that negative 8xh, and I'd have negative x. I'm going to pull it from this guy first, plus 1, and then minus 4h. I did that because of order. I pulled an h from 4h squared, and there's an h down low. This is the cancellation. And this is what I'm left with. That's the difference quotient, which is also known as a derivative. It's a derivative. Identify all asymptotes of f of x equals x plus 6 times x squared minus 9x minus 10. You know, don't be the kid who says x is negative 6. Hayden Burris. Don't be that kid. We're going to focus on some of our rules. You cannot divide by 0. So I know that x squared minus 9x minus 10 cannot be 0. This is where your vertical asymptotes are going to be. We're just going to factor. What, negative 10 and positive 1? Negative 10 times 1 is negative 10. Negative 10 plus 1 is negative 9. Still not 0. So x is not 10 or negative 1. Now these are my vertical asymptotes. The vertical asymptotes are ironically at x equals. Now, I know that seems weird to some kids, but that means you don't know what a vertical asymptote is. A vertical asymptote is a line you cannot cross. You will not cross it. The other one here, on this particular example, you should realize that you can't do long division. I guess you could, technically. Let's go over long division. I'm not saying you can't, I'm just saying you shouldn't. But long division always yields asymptote. Always yields the asymptotes. Always yields asymptotes. Now, will x plus 6 enter x squared minus 9x minus 10? No. 0 times. Which, coincidentally, is what the horizontal asymptote is. The horizontal asymptote is y equals 0. So that's the deal. And maybe you remember this lesson, maybe you don't, but we had x over x squared, and that was kind of a rule. The horizontal asymptote is at y equals 0 if the degree of the denominator was higher than the degree of the numerator. But you can always fall back on long division. It's one of the reasons I like it. 14, now we have something that's the bane of so many children, even and odd. And I don't know why. Do what it tells you. So you see this little check? I'm going to run that little check. I'm going to figure out what f of negative x is. F of negative x happens when I let every x that I see become negative x. All right, so if I take something like a negative 1 and I raise it to the 5th, I still have a negative 1. So this becomes 2 times a negative x to the 5th, which becomes negative 2x to the 5th. And the same thing with a cube. If I cube a negative, I'm still negative. So I have 2 times negative x cubed. Notice what I'm doing with the cubes and the fifths, which becomes minus 2x cubed. And then this guy becomes minus 2x. Now, there's f of x. This is not equal to f of x. So f of negative x is not equal to f of x, therefore not even. All right? Now let's do the next check. Little negative symbols over there. Find negative f of x. Negative f of x is found by wrapping the entire stinking thing in parentheses and multiplying it by a negative. And I've done this a long time, and I don't understand why kids struggle with this so darn much. Like, it's not hard. Just follow a rule. Is that the hard part, that we just won't follow a rule? So compare and contrast between these two things. What my piece of paper is showing me is it's showing me that negative f of x is in fact equal to f of negative x. So this is the definition of odd. We have an odd function. And it is kind of odd. It's kind of odd because you have symmetry with the origin. You know, this is, it's just kind of weird. That's all. All right. Restrict the domain so that f of x is 1 to 1 and the inverse of g of x is x minus 5, quantity squared plus 6. State the domain of f of x and of the inverse and state the range of the inverse. All right, so, think about the graph. It's all about graphing. Everything in mathematics is about the graph. We got a right 5. We have an up 6. And I'm not saying you have to do this on your test, okay? The truth is you're in pre-calculus and you ought to be able to visualize this. You ought to, but I can't say look at the graph and expect you know what I'm talking about, so I gotta draw the darn thing. Anyways, that's what the graph looks like. And the reason we have to throw away some of this is this thing fails, boy, that's bad, the horizontal line test. So we chunk half the graph. We always keep the increasing stuff. That's the piece we always keep. We keep what's increasing. So we're keeping, for our domain, we're keeping all values of x such that x is greater than or equal to 5. That's what we're keeping, which I'll probably have written down with a hard bracket of 5 to infinity. And that is the domain for both g of x and its inverse, because domain is inherited from the original function. So now let's go through the process of writing the inverse. Step 1 is we swap x and y. So on this one, we get the g out. X is y minus 5 squared plus a 6. And now we're in step 2, which is solve for y. And our goal is to get in here. That's your goal. We're going to subtract the 6. X minus 6 equals y minus 5 quantity squared. And then we're going to fix that squaring by square rooting both sides. So we'll have the square root of x minus 6 equals the square annihilates the understood 2 on the root, y minus 5. We'll add 5 to both sides outside of the square root symbol. And then we'll do our replacement. That's the last step. State that it's the inverse. That should be g of negative 1 of x. So this one's, oh, that's a 6, isn't it? Well, why did I change that to a 6? Oopsie poopsie. Don't know what happened. Back to this step, we'll have the root of x minus 6 and 5 is equal to y, and then we'll use our correct notation, because that's the last step. And again, that's a g, not an f. All right, so if you think about this guy, root of x minus, actually, let's just use my grid here. This is up 5, right 6. Right 6, up 5. 3, 4, 5. It looks like that. You can kind of see that the range here for the inverse is 5 to infinity. I'm not too surprised they match. Really not. Anyways, there you go. There's 15. I think there's one more to do. It's a function composition. I remember when we tested on this stuff, you guys did not like your fractions, and it's just expected of you. There's nothing I can do about it. Find the domain of f of g of x. So the classical notation here is that. So what this is saying, it's saying every x in f becomes g of x, which is 3 over x minus 5. I just had a brain fart. Anyways, I'm going to take that and I'm going to put it right there. Now I have to do this first. Okay, so I have 1, I've encountered an x, it becomes 3 over x minus 5, and then there's the plus 4. I may as well clean that up a little bit. I'm left with 3 over x minus 1. All right, so there's a couple of things going on here. Focus on your denominators. You see that little guy right there? Can't divide by 0. X cannot be 0. But wait, there is more. That's the sad part about this. There is more. There's more going on. You need to think about the entire denominator. All of that cannot be 0. All right. We'll add 1 to both sides. 3 over x is 1. What is my phone? No. Interesting. Anyways, I'm sitting there, and by the way, not 1, because we're finding things that x cannot be. And the issue with x here is its location. It's in the denominator. We're just going to clear the fractions. Just multiply both sides by x. 3 is not x, and it's done. So x is not 0, and x is not 3. All right, now the fun part. The fun part is simplify your answer such that it is a unified fraction. So I'm sitting at 1 over 3 over x minus 1, and I need a unified fraction. I probably should have used better terminology here. The issue is that this thing is what we call a nested fraction, which is a fraction within fractions, and that's kind of ugly. So what we'll do is we'll focus on this 3 over x minus 1. I'm just going to focus on the denominator. You know as well as I do that if you're going to add or subtract fractions from each other, you must have a common denominator. So think about this being over a 1. We're going to give this 3 that 1, which means we give that x that 1. And this is just something, it's kind of understood. And I need this 1 to become an x. So I'm going to give it an x, which means I'm going to give this guy an x. So 3 times 1 is 3. Take away 1x. And now we have common x's down there. Okay, that's part of it. So now I'm sitting at 1 over 3 minus x over x. All right. How do I divide by a fraction? To divide by a fraction, we multiply by the reciprocal. Now I'm showing you this the long way right now. I'm about to show you the quick way. So I've got the 1, which is technically this guy right here is 1 over 1. Okay, that's this piece. I'm going to multiply it by x over 3 minus x. I flipped this guy. It's the one that gets flipped. Then I get x over 3 minus x. And this is the correct one. And this is also when the fact that I can't be 3 shows up. I like to do it ahead of time because, I don't know, I'm just weird like that. All right, so now that was the longest way of doing this. Nested fractions can be cleared up super, super quick by multiplying by the denominator within the fractions. So, all right, so how do I word that properly? To clean up a nested fraction, multiply all terms within, so within this thing, by the, what we call least common denominator. And the least common denominator that all three things here could have is x. That's the one I'm going for. Which in this case, and it's in this case only, it's x. So let me show you what I mean by that. Just take the whole thing and distribute an x to every single piece. Every single piece is going to get that x. All right? So 1 times x is x. Now I'm here. I'm thinking x times 3 over x, and the x's cancel. That's 3, and then x times -1 is minus x. That is the quickest way to do it. It's so much quicker than the other technique, but how many of you are going to watch this video? I don't know.